Okay, so picture this with me. You're scrolling on your laptop, and boom, you see a photo of a bedroom. Totally normal, right? But here's the catch. This photo, it wasn't taken by a person. A machine made it from scratch.
It's wild, right? And the machine didn't just like piece together parts of other photos. It actually generated it. Like it dreamed it up.
Okay, that's kind of creepy, but also super cool. So how does a machine learn to, like, become an interior decorator?
Well, it all starts with these things called GANs, generative adversarial networks.
GANs. Catchy. Okay, so break it down for me. What are we talking about here?
Basically, imagine two neural networks, right? But instead of working together, they're like rivals.
Rivals, like they're competing.
Yeah, exactly. One of them, called the generator, is trying to create these realistic images, and the other one, the discriminator, is trying to tell if they're real or fake.
Okay, I'm kind of seeing it. It's like one's the artist and the other one's the critic.
Exactly. The generator is like the artist just throwing stuff at the canvas, and the discriminator is the critic saying, nope, that doesn't look real.
So they're constantly trying to outdo each other.
Exactly. And here's the thing. That back and forth, that's where the magic happens. That's how they both get better.
It's like they push each other to improve.
Yeah, exactly. The generator has to keep getting better to fool the discriminator, and the discriminator has to keep upping its game to spot the fakes, like AI sharpens AI or something.
I like it. So we're talking about this paper, Unsupervised Representation Learning with Deep Convolutional Generative Adversarial Networks. Why is this paper such a big deal?
Well, for a long time, the focus in AI was on supervised learning, right? Like, we feed the machine a ton of labeled data, like, this is a cat, this is a dog, that sort of thing.
Right, like teaching a kid with flashcards.
Yeah. But what we really want is for machines to learn like we do without needing someone to hold their hand every step of the way.
We want them to figure it out on their own, like unsupervised learning.
Yeah, exactly. Think about how you learned about the world. You didn't need a million labels to figure out what a cat was, right? You just observed, you interacted, and you learned.
Okay, so what's been holding us back from this whole unsupervised thing?
It's hard. The real world is messy. There's so much variation, so many subtle patterns.
So how do we get machines to see the world like we do?
Well, that's where this paper and these DCGANs come in. Earlier attempts at, say, generating images, they often ended up with these blurry, kind of unrealistic results. This paper was a big step forward.
So these DCGANs, they're like the next generation.
Yeah, they're able to learn much more complex and nuanced representations of data. Like, they're not just mimicking, they're actually understanding.
Okay, so let's dive into these DCGANs.
Mhm.
What makes them so special?
Well, DCGAN stands for Deep Convolutional Generative Adversarial Network. They took that whole two-network rivalry thing we talked about and added some really clever tweaks.
Give me the inside scoop. What kind of tweaks are we talking about?
So one of the big things they did was replace these things called pooling layers with strided and fractional strided convolutions.
Okay, full disclosure, I'm going to need that in English.
Right, right. It's basically like giving the network a better pair of glasses.
Yeah.
You know, instead of seeing a blurry bedroom, it can pick out the details, the furniture, the textures.
This is like higher resolution for AI.
Yeah, exactly. It helps them understand how those little details fit together. But when you've got all that extra information flying around, things can get a little,
Unstable. Like the whole thing could go haywire.
Yeah. And that's where they introduce batch normalization, keeps everything in check during training.
Okay, so it's like the AI equivalent of like a safety net.
Yeah, something like that. Make sure the whole system stays balanced.
Okay, got it. Strided convolutions for sharper images, batch normalization for like keeping things from going off the rails. What else makes these DCGNs special?
Oh, they also mess around with different activation functions. It's a little technical.
Yeah, let's not get too deep in the weeds.
Right. Basically, these functions, they control how information flows through the network.
So like traffic signals for data.
Yeah, that's a good way to put it. And all these little tweaks, they made a huge difference.
So we're talking about more than just prettier pictures here.
Oh, absolutely. This was a game changer. We finally had a system that could be trained on huge amounts of data and generate realistic images. But the really cool part is that it could learn on its own without us telling it what it was looking at.
Okay, enough with the tech talk. Show me what these things can do. What kind of images are we talking about here?
All right, so they trained these DCGANs on this massive data set of bedroom images, millions of them.
Wait, millions. That's a lot of bedrooms.
Right. And after training on all that data, the DCGN could generate completely new bedrooms. And not just like blobs of color, but actual bedrooms with furniture and windows and everything.
No way, like I'm looking at some of these images from the paper and they look real.
That's what everyone thought. The detail was incredible. But the big deal was the unsupervised learning part, remember? No one told the DCGAN what a bed or a window was. It just figured it out by looking at all those images.
So it's like it developed its own sense of like bedroomness.
Exactly. It wasn't just copying, it was understanding, and that was huge.
Okay, that's amazing. But how do we know what's going on inside these networks? Like, can we ask it, hey, what makes a bedroom a bedroom?
Well, it's kind of a black box, but researchers figured out some pretty clever ways to peek inside. One of the techniques is called walking in the latent space.
Walking in the latent space. Sounds trippy.
It's actually simpler than it sounds. Think of it like a control panel with a bunch of sliders, and each slider controls a different feature of the generated image.
So like one slider for the size of the window, one for the color of the walls.
Exactly. By moving those sliders around, you can actually see how the network understands different bedroom features.
So by playing with these sliders, we can see what the network thinks is important in a bedroom.
Yeah. And what they found was that these features, they weren't just random, they corresponded to actual things in bedrooms. You can make a window appear or disappear just by moving a slider.
Wow. It's like the network learned this secret language of bedrooms, and now we're starting to understand it.
That's a great way to put it. And it's not just about generating images either. When they looked at the discriminator, the critic, they found that it was learning to recognize specific objects too.
So it's not just saying real or fake anymore. It's saying that's a bed or that's a lamp.
Exactly. And again, it learned all this by itself without any labels or instructions, just by analyzing all those examples.
Okay, this is all super cool, but like, I'm not trying to design bedrooms here. What's the big takeaway for those of us who aren't like AI researchers?
Well, this research, it opened up a lot of doors. It's not just about pretty pictures, it's about teaching machines to understand complex data, and that has implications for everything.
Okay, I'm listening. Give me an example.
Remember how we were talking about walking in the latent space, like messing with those sliders?
Yeah, like the AI control panel for bedrooms.
Right. So get this. You can actually do math in that space. Like you can add and subtract concepts.
Hold on, we're doing math with ideas now.
Yeah, it's kind of wild. Imagine you have a vector, right, like a bunch of numbers, and it represents the concept of man with glasses. And then you've got another one for woman with long hair. Now, if you subtract the man vector and add the woman vector, what do you get?
A woman with glasses and long hair.
Bingo. You're basically doing surgery on these abstract ideas, and the network just gets it.
That's kind of blowing my mind right now. So what, we can just like mix and match different features to create whatever we want?
Pretty much. You can imagine using this to design new products or create characters for a video game. The possibilities are huge.
So, to sum it all up, this paper, it wasn't just about making cool images. It was about proving that machines can learn to understand the world in a really deep way all on their own.
Exactly. And this was back in 2015, right? Since then, GANs have gotten even crazier. We're talking photorealistic images of people who don't even exist, AI-generated art. It's kind of mind-blowing.
Yeah, it's exciting, but also a little, I don't know, unnerving. Like, what happens when machines are better at art than we are?
It's a good question, and I don't think anyone has all the answers.
Yeah.
But I think the important thing is that we use these tools responsibly, you know? It's up to us to make sure AI is used for good.
Couldn't agree more. Well, on that note, I think it's time to wrap up this deep dive into the world of DCGANs. But before we go, I want to leave you with this. If machines can learn to understand something as complex as a bedroom just by looking at pictures, what else might they be able to learn in the future? What other hidden patterns are out there just waiting to be discovered? Thanks for joining us, and until next time, keep exploring those big questions.